All right, on the practice exam for questions 1, 2, and 3, you need to include these notes on your note card, and that will help you figure out what type of graph it is. For instance, number 1 is exponential because it's a smooth curve going either up or down. So number 1 is C. Number 2 looks like a U or an upside down U. So if I look up here, that would be a quadratic. And number 3, we would have to graph that on our calculator. It should look something like this. Crosses at -3, goes up 4 and over 1, and it's a straight line. So number 3 is linear. For number 4, you would want to include what I just wrote down in black on your note card. This will help you remember which one is your independent and dependent variable. So in this situation, they are asking what is the independent quantity, and the independent is my x-axis. So independent is time in minutes. For questions 5 and 6, you would simply graph these on your calculators, and I've included what the graph should look like over on the right-hand side. And we are trying to figure out which statement is true. Now, the top one is an absolute value equation, and since it has a bottom point, and I'm putting that in purple, we can say it does have an absolute minimum because it has a lowest point. On number 6, we graph that on our calculator also, and it's a quadratic because it's a smooth curve. It looks like a U or an upside down U. And we are asking ourselves, does it have a highest point or a lowest point? And it has a lowest point or a minimum value. So both 5 and 6 do have lowest points, minimum values. On number 7, it says, what is the classification of the function? And if I go back to my notes over here, I'm going to look for the one that matches, and I graph it on my graphing calculator, and it's going to give me the graph over to the right of your screen, which is a quadratic. So numbers 1, 2, 3, and 7 all use the same notes. On number 8, which graph represents a function? Now remember, this is the vertical line test. If I can draw a vertical line and only hit once, it is a function. On part A, if I draw a vertical line, I hit once, twice, 3 times, 4 times, and 5 times. So this one is not a function. On part B, if I draw a vertical line, I could draw one right here and I hit twice, which means not a function either. On part C, if I draw a vertical line, I can hit twice on this one also, which means part C is not a function. And on D, if I draw a vertical line here, I only hit once. If I draw a line here, I only hit once. No matter how many times I draw my line, I will only hit once. So D is my answer. Number 9, what is the common difference of the sequence? What are they adding every single time? And it looks to me like they're adding 2, so my common difference is 2. Number 10, what is the common difference of this sequence? Now again, arithmetic is adding or subtracting, and this time it is subtracting 10, so my common difference is 10. On number 11, what are the next 3 terms? Well, if I look, it appears to be adding 9 every time, so the next 3 terms would be 32, and if I add 9, 41, and if I add 9, I get 50. Number 12, what is the common ratio of this sequence? It appears that they are multiplying by 3 every time, so all I'd have to do is say the common ratio is they're multiplying by 3. Number 13, what is the common ratio of this one? Now, it looks like they're dividing by 2, but we're not allowed to say dividing. So we have to find a loophole around that and say they're multiplying by what number? And since it's taking half every time, they are multiplying by 1/2. Number 14, what are the next 3 terms of this sequence? And again, it looks like they're multiplying, which makes this a geometric sequence. They're multiplying by 3 every time, so I would just keep multiplying by 3. 36 times 3 is 108. 108 times 3 is 324. And 324 times 3 is 972. Number 15, determine the type of sequence. So we need to figure out, are they adding every time or are they multiplying every time? So to go from 16 to 26, it looked like they added 10, and they also added 10 again. So on this problem, they are adding every time, which would make this one an arithmetic sequence. For number 16, you want to include what I just wrote in purple on your note card. That is the arithmetic explicit formula. Now to write the formula for this sequence, a sub n equals, a sub 1 is the first term, which is 8. The common difference is they're adding 4 every time. So I'm going to say plus 4 parentheses n minus 1, and that is my explicit formula. For number 17, you will want to include the formula for the geometric explicit formula, which is written in purple. So G sub n equals G sub 1 is my first term, which again is also 8 times the common ratio, and it looks like they're multiplying by 2 every time, so my common ratio is 2 raised to the n minus 1 power, and that is my answer. For number 18, to find the 18th term of the sequence, I need to write my explicit formula first. So it's arithmetic, so because they're adding 5 every time, so A sub n equals 20. They're adding 5 every time, parentheses, n minus 1. Now to find the 18th term, I need to plug in an 18 for my n. So on my calculator, I would type in 20 plus 5, parentheses, 18 minus 1, and that will give me the answer of 105. So 105 is the 18th term of the sequence. All right, on number 19 and 20, this is the correlation coefficient and linear regression, and I wrote the steps over on the right of my screen in black. So I want to walk you through how to do this on your calculator. On number 19, the table shows atoms' range and shoe size, and what's the correlation coefficient. So for my age, I'm going to enter them in for L1, which is my X, so I'm going to hit Stat. Then I go hit Enter on Edit. And my X column, or the L1, I'm going to put in 6, 8, 10, and 12. Then for my Y, the shoe size, which is your list 2, I'm going to put in 3, 4.5, 5, and 7.5. Then over on step 3, it says hit Stat again. I go to the right once to where it says Calc. I choose option 4. And then depending on your software, mine says to go down to Calc and hit Enter again, and all of these numbers will pop up. And we are looking for the correlation coefficient, which is the R value, and your R value on this one should be positive 0.966. Now on number 20, again, the table shows Savannah's salary for different years. Now do you see how it starts off with the year 2000? But we want to do it for the numbers of years since 2000. So when we enter these in our calculator, we're going to put in 0, 1, 2, and 3. So we're going to do the exact same steps we do again. So I'm going to go over to my calculator. I'm going to hit Stat, hit Edit, and then I'm going to clear out the numbers beforehand. So I put my cursor up on L1 and L2, and I hit Clear and Enter, and then I type in these new numbers. So for list 1 or my X's, I'm going to put 0, 1, 2, and 3. For list 2 or my Y's, I'm going to put 40,000, 42, 46, and 44, 5. Now, once I do that, I go over to my steps, and I'm going to hit Stat again, go to the right once to Calc, choose option 4, I go down to Calc and hit Enter, and it's going to pop up that my A value is 1,750, which is my slope, and my B value, which is my y-intercept, is 40,500. So that's my equation for the linear regression. For number 21, which scatter plot is most likely to have a correlation coefficient of positive 0.5? Now, positive means if I draw a line, it should be going up. So if I skip over to part D, if I were to draw a line of best fit, it looks like that one's going down. So it can't be D. On part B, if I was to draw a line of best fit, it looks like it's almost even, not really going up or down. On part A, it looks like it is also about even, not really going up or down, so it can't be part A. And part C, if I was to draw a line, it looks like it's going up. So since it's a positive 0.5, part C has to be my answer. All right, for number 22, write the arithmetic sequence in linear form. Now you may want to put this exact example on your note card to help you remember. To convert this, the first thing I need to do is the distributive property. So I'm going to bring my 10 straight down. 4 times n is 4n, but I'm going to use x. And 4 times negative 1 is negative 4. Now from here, I see like terms, 10 and negative 4. So I can put those together. So I'm going to bring down my 4x, and a positive 10 and a negative 4 gives me a positive 6. So this is the linear equation. Number 23. Determine what f of 10 is. Now, since 10 is in the parentheses, that is my x. So it's negative 2 times 10 plus 10. And when I type that into my calculator, I'm going to get an answer of negative 10. For 24, again, determine for f of 6. And since 6 is in the parentheses, it is my x. So it's 3 times 6 minus 5. And 3 times 6 minus 5 is 13. For number 25, we need to write the function of the equation. Now, to do this, we need the slope and the y-intercept. So I'm going to find the slope first. From here to here, it looks like it's going up 1. From here to here, it's going up 125. And to get that slope, it's simply 125 over 1, which is 125. So my slope is 125. Now, we need to get the y-intercept. So I'm going to choose a random point over here, whichever point I think looks the easiest, and I'm going to plug it in so I can get my slope. I think 0 and 300 looks the easiest, so I'm going to plug those in. The 0 is my x, and the 300 is my y. And now I can solve this and get my y-intercept. 125 times 0 is 0. So what I have is 0 plus b, and 0 plus b is b. So it looks like my y-intercept is the number 300. And now that I have my slope, 125, and my y-intercept of 300, I can write my equation, and it's in purple. Number 26, identify the y-intercept of the function. Well, we just got to look up here and look at this number right here. Negative 10 is our y-intercept. Number 27, determine the slope of the 2 points. Well, if you remember, we always label them x in point 1, y in point 1, x in point 2, y in point 2, and we plug them into this formula, y2 minus y1 over x2 minus x1. You may want to include that on your note card. When I plug them in, I'm going to get y2, which is 12, minus y1, 4, over x2, which is 3, minus x1, which is 1. And that's going to give me an answer of 8 over 2, and 8 divided by 2 is 4. So my slope is 4. For number 28, we're going to solve this equation for x, and I see the distributive property first. So 3 times x is 3x. 3 times negative 4 is negative 12. From here, I'm going to do upside down t's and solve it. The opposite of subtracting 12 is adding 12. So we get 3x equals 30, and the opposite of multiplying by 3 is dividing by 3, and we get x to equal 10. For number 29, again, we're going to solve this one using upside down t's, and there's variables on both sides, and we always like to bring the smaller variable to the larger variable. So 5x and 4x, the 4x is smaller. The opposite of a positive 4x is a negative 4x or minus 4x. So we get 1x, or just x, bring down my negative 8, bring down my equal sign, and bring down my plus 4 over there. From here, to get the x by itself, simply add 8, and x equals 12. For number 30, we're going to solve this one, but we see the distributive property first. 3 times x is 3x, 3 times 4 is 12. Over here, 2 times 2x is 4x, and 2 times 5 is 10. Now I see variables on both sides. I always bring the smaller variable to the larger one, and the opposite of a positive 3x is a negative 3x. So we get 12 equals 1x, or just x, plus 10. And then finally, we're going to subtract 10. And we get x to equal 2. Now number 31, on the practice test and on the real test, we are going to omit number 31. And we are also going to omit 32. On number 33, convert from standard form to general form. General form means get the y by itself, and I wrote it over there in blue already. So we're going to do upside down t's and get the y by itself. So to get the y by itself, we have to get rid of whatever's on the same side, and it looks like there's a positive 3x on the same side. The opposite of a positive 3x is a negative 3x. So I get the y equals, and I'm going to bring down my negative 3x because I can't combine him. He's not like terms. And I bring down my positive 6. And this is my equation in general form. For number 34, solve the equation for x. So I'm going to do upside down t's and solve this. Now, there's a b and a c on the same side. I have to get rid of the c first because it's being added, and the opposite of adding c is subtracting c. So I get bx equals d minus c. And finally, to get the x by itself, the opposite of multiplying by b is dividing by b. So I get x equals d minus c all divided by b. For number 35, to solve the equation for t, I need to get the t all by itself, and there's an r on the same side, and the opposite of multiplying by r is dividing by r. So I get t equals d divided by r, and that's my answer. Number 36, I just need to solve this inequality, and we're going to do it the same way we've been doing it. The opposite of subtracting 8 is adding 8. So I get 2x, and I do not flip my symbol on on adding or subtracting. So I get 2x is less than or equal to 14. And then I need to divide by 2. And again, I do not flip my symbol when I divide by a negative. I'm sorry, when I divide by a positive 2. I only flip it when I divide or multiply both sides by a negative. So I get x is less than or equal to 7. All right, on number 37, we have to write the inequality for this graph. Well, I'm going to use the variable x. Since it's shaded to the left, that's less than. Since it's an open point, I do not put an or equal to. And it's an open point at 10. So my answer is x is less than 10. For number 38, solve the compound inequality. This is where I always say do a double upside down t to get the x by itself. And we're going to add 6 to all three parts to get the x by itself. So I get 16 is less than or equal to 2x. Which is less than or equal to 28. And then another double upside down t to get the x by itself. The opposite of multiplying by 2 is dividing by 2. And we get 8 is less than or equal to x, which is less than or equal to 14, and that's my answer. On number 39, I wrote the instructions on how to solve this one on your graphing calculator. You're going to type both of these equations in on your y equals. Then you hit zoom 6 or graph, preferably zoom 6. Once you're at the graph, you're going to hit second calc, choose option 5, the intersect, and then hit enter 3 times, and it will give you the answer of -1, -3. Number 40, since we have an x all by itself right there, that's our signal to use substitution. So since that x is by itself, we scribble out his twin, but we have to put in something of equal value. So I need to put in a 3y right there. So I have 2, but instead of times x, it's times 3y. Plus y equals 7. 2 times 3y is 6y. 6y plus 1y is 7y. And if I do an upside down t, the opposite of multiplying by 7 is dividing by 7, and we get y to equal 1. So we know in our answer, the y value is 1. Now we always go back and get the other variable. I'm going to choose to use my top equation, and since y is 1, I'm going to plug in a 1. So x equals 3 times 1, which means x equals 3. So my answer is written in blue, 3, 1. On number 41, solve this system of equations by addition. So I already have opposites. The x's will cancel. So because I have opposites, I'm going ahead and wrote my plus and drew my line. The x's eliminate. I get -1y equals +4. Then I need to solve that. The opposite of multiplying by -1 is dividing by -1. And y equals -4. So in my answer, I know the y value is -4. Now we always go back and get our other variable, so I pick which equation written in black looks easier to me, and I think it's the bottom one. Since y is -4, I'm going to plug a -4 in right there. And now I'm going to solve it. 4 times -4 is -16. And upside down t, add 16. So I get 4x equals 4. Then I divide by 4, and x equals 1. So my answer is 1, -4. Number 42, what is the solution to this systems of equations being graphed? So the solution is where they intersect. So that little blue dot right there is my answer. Now if I look down on the x-axis, I believe the answer is 4.5. And now I need the y. So if I look over, it looks like it's 45. So my answer is 4.5, 45.